Okay, so what we're going to do today is our notes and the assignment that goes along with it. So make sure that you have your notes out and that you are on the next blank page. Our topic today is fractions to decimals. And as we're going through these notes, guys, we can pause the video at any point in time if you guys need to. This is also in the content library in your class notebook. If you want to copy them and then go through the notes with the video, that might be helpful. So our essential question for today is, how do you know whether a fraction is going to terminate or repeat? Okay, so we've got some vocabulary to go through, and then we have some steps and some lovely handwritten stuff from my computer that you guys are going to see are so much better at writing with your computers than I am. And then we're going to go through some guided practice. So for our definitions, we have a rational number. So remember I said that we are going to start dealing with some positive and negative fractions and decimals as well as whole numbers. To cover that, we call those rational numbers. So a rational number is any positive or negative number that can be written as a fraction. So that's those positive and negative fractions and decimals as well as the integers. So when we have a terminating decimal, it is a decimal that ends in a 0 and does not repeat on forever. So these are our decimals that we're used to dealing with most of the time, like 0.35, 0.2, 0.50. All of those end, and so those are called terminating decimals. We also have repeating decimals, and we've dealt with these before. And these are decimals that go on forever, they never end, and they have a repeated pattern. Okay. And so remember that when we have a repeated pattern, this can be shown with a ... after the repeated pattern or a bar over the repeated pattern. You guys notice I missed the N right there. Sorry about that. So pattern. So again, we have rational numbers, and then we have either terminating or repeating decimals. So we're going to learn some quick tricks and some unit fractions that will help us understand if it's going to be a repeating or a terminating decimal if I decide to convert it. And this is going to be really important when we start dealing with problems that have fractions and decimals in them. If it turns out to be a repeating decimal, I don't want to convert that to a decimal because it's going to keep going on forever. Okay. So our steps that we're going to have in our notes are for our division strategy. I know that we've dealt with equivalent fractions as well, but we're going to go ahead and get our division steps in there just as a reference for us. Not every one of these is going to be able to be made into an equivalent fraction with 10 or 100 or 1,000 in the denominator. So that's why we are putting these conversion steps in here. So when I'm given a fraction, I'm going to put the top number inside the house, the numerator, and then I'm going to put the bottom number outside of the house, the denominator. Okay, so remember that the rule is not the biggest number always goes outside. That's not a rule. So remember, order matters with division. So whatever is up top or comes first goes inside. Whatever is on bottom or comes second goes outside. And then after I set that up, I'm going to use decimal division rules until the decimal ends in a 0 or a pattern repeats. Okay? So down here we have some unit fractions, and you guys know I have some lovely handwriting down here that I tried to do for you guys. But these are written down because these are denominators. When I see those are triggers for repeating decimals. Okay, so every single time I see one of these numbers in a denominator, no matter what the top part is, it's going to give me a repeating decimal. The only exception to that rule is if I have a number up top that the bottom number can go in evenly. So, for example, if I had a 3 up top, 3 can go into 3 evenly, so obviously that's not going to repeat. Just like for 6, if I have a 12 up top, 6 can go into 12 evenly, so that's not going to repeat. But any other time that the bottom number can't go into the top number evenly, it's always going to give me a repeated decimal. Even if I had 2 in the numerator, right? 2 over 9 is still going to give me a repeated decimal. It's just going to be increased a little bit because now I have 2 9ths instead of 1 9th. So make sure we get these down. I'm just going to read through them really fast because my lovely handwriting, you might not be able to tell what some of them say. So 1/3 is going to give us a 0.3 repeating, and notice how the bar is over the 3, or I can write it as 0.333 ... So normally we'll show the pattern 3 times and then write the ... For the next one, the only thing that repeats is the 6. That's why the bar is only over the 6. So I'm going to write the 1 and then the bar is only over the 6 because that's the repeated pattern, is the 6. And then for this one, I didn't write it over here for the decimal ... notation because I would have to show this repeating 3 times and I would run out of space if I wrote that over there. But you can still write the ... instead of the bar. So it says 1, 4, 2, 8, 5, 7 in case that was hard for you guys to see. So that's a bar over top. And then for 1/9, that's just 1 repeating on forever. So that's why the bar's over the 1, 1, 1, 1, ... And then for 1/11, it's 0.09 repeating. So 0.090909 ... And then for the last one, it's 0.08 and the 3 repeats. So the only thing that repeats is the 3, which is why that's the only thing that has the bar over top. And over here we have 333 ... after the 08. So that's for the notes portion. The next video is going to go over your guided practice. So make sure you have all of your notes written down, and we're going to go through the guided practice next.